Hi, my name is Dr. Nathan Green. I'm a professor of practice here in the School of Engineering and Engineering Technology and in the Electrical and Computer Engineering Department. And I'm the faculty sponsor for the LEGRANGE Senior Design Project. The idea behind LEGRANGE, it stands for LeTu Emulated GPS Range, is we are going to develop a test range that will allow us to study GPS-like signals and radio navigation signals where we can set up a controlled environment that will let us broadcast our own navigation signals that look just like a GPS signal, except they're in a different part of the frequency spectrum. And so what that allows us to do is to experiment and to study and see what really goes on whenever there are challenging environments with jammers and other broadcasters that are trying to interfere with the authentic good signals. And we want to be able to do this in this emulated range because if we were to try to do something like this with actual GPS signals, well, that violates several dozen laws and sends us all to prison. So what this project is designed to do is to give us an ability to study with actual radio signals, with actual live electromagnetics, I guess, what's going on in a way that we couldn't possibly do if we just had the real authentic GPS signals. And it's been a real pleasure. We get to do a lot of work with a whole range of students from electrical, computer science and engineering, mechanical, and even materials joining. And with me this morning, I've got Aaron. So Aaron Wells is our mechanical team lead, and he is a materials joining engineering major. And so Aaron, if you could tell us a little bit, what's it like to be part of this big interdisciplinary team working on what some people would think of as an electrical engineering project?
So it's really interesting being a non-electrical engineer on a project that deals mostly with electrical engineering, I guess, big electrical engineering details. But there are a lot of other areas that require other disciplines to work on the project with. As an example, like Dr. Green said, I'm the mechanical design sub-team lead, and what we're working on as the mechanical group is getting this system actually in a physical space on campus that we can use and work with. And so there were a lot of hurdles to overcome when it comes to how do we implement this system physically, because we've got all of the designs and all of the algorithms working on being written, and there's this actual system that needs to be put up. Where do we put it? How do we implement this? How do we work with the local authorities to make sure that we're out of everybody's way, and all of those kinds of things that go into any sort of physical space. And so one thing that we're doing right now is we are taking these boards that you see in front of you and this antenna, and we're actually putting them on telephone poles outside and doing the design work to make sure that our enclosures are strong enough to support the loads that they'll endure and be able to withstand the elements that are outside, be able to run the tests effectively without interfering with any of our signals. And so that's really important when it comes to mechanical design, because you have to think through all of these details from these other disciplines, like what is say aluminum going to do to our RF signal? Is it going to block it? Do we have the right shielding on the boards so that we're not actually going to cause any real interference? Or what kind of temperatures do we need to make sure that our enclosures stay below? That way we can make sure all of our boards are operating effectively. So all of these kind of ideas cross over from the realm of electrical and computer science to this mechanical design world that I've been working in most of this semester. And it's really enjoyable to be able to see the whole range of engineering disciplines come together so that we can do good work that has a real purpose out in industry that our national labs can use.
Mm-hmm. So one of the great things about senior design here at LeTu is we really have the culmination of all of our coursework coming together. All of our different classes are used and embodied in one big project. And this is really able to be seen in our boards, because every part of this board has been designed and every component has been specifically selected to fulfill its specific purpose. And on this board we have digital signal processing, we have analog circuit design, we have radio frequency communications, and then there are also control systems that go into this, which is a class that you take as a junior or senior depending on your major. All of that is done by bringing together all of the concepts from our whole curriculum. Our whole electrical and computer engineering curriculum comes together on a single board, and then to deal with all of the other aspects, we have to bring together the rest of our disciplines to deal with the fact that this microcontroller on this board, if it gets too hot, it releases the magic smoke and the project is over, right? So we have to make sure that our whole team works together to keep the whole system in mind as we deal with all the different aspects of it. I think another really important thing to keep in mind as you are, you're a high school junior, you're a high school senior, and you're starting to think about what you're going to do with the rest of your life, and then you see an engineering project like this one or any of the other 10 senior design projects we have at LeTourneau right now, and you think, I could never do that. Well, guess what? You're right, in that you as one individual could not do this whole project. But a good engineering team is like the body of Christ, right? In the body of Christ, we have one body and every person has a role to play. Every person is a part of the body of Christ. And on an engineering team, this year I have a team of 14 students that are working on this project. And every student has a particular expertise that they have developed over the last 3 years. And as they have gone through the process of refining, they've started off as, maybe we have one student that came in and they were good with their hands, but they struggled with calculus. Or maybe you had a student come in that had already taken Calc 1 and Calc 2, but they had never touched a welder in their life, right? One of the things we do at LeTourneau is we take this broad section of students and we shape and mold and help them to become the engineer, the person that God has them to be. Because no one person starts off knowing anything, and no one person ends up knowing everything, right? You will grow, you will become the person, the engineer, and if you're in a different department, the nurse, the teacher that God desires for you to be. And that's why I teach at LeTourneau. I teach at LeTourneau because I want to be a part of discipling the next generation. Because when I graduated from LeTourneau in 2007, my faculty shaped me. My faculty were part of the process of discipling me, and it's a great joy to be a part of that process.